Hey guys, in this video we are going to see binary tree in order traversal. So let's get to it. So this is the recursive solution for in order traversal. As you can see, we first go traverse the left subtree, then we visit the root node, and then we traverse the right subtree. That is the basic idea in recursion. And since we are like recursive solution is trivial, we will be doing this iteratively now. We can just comment it out and work with our iterative solution. So first thing we will do is, if root is null, that is if not root, we know that we don't have to do anything and we will just return the empty list. Now we will do this in order traversal using a stack. So let's initialize a stack and resulting list that we have to return. Stack will be empty as well as the returning list will be empty. Now we will take a current node and initialize it with the root. So while our stack is not empty, that is while stack, remember in order traversal we traverse the left subtree first. So considering this tree on the left side, we the root is 1, we have to first traverse this subtree, right? So we go to 2, then we go to 4, and this is the leftmost subtree, this is the leftmost node. So we will first visit this, and now we will visit this node, and then we will go to its right subtree. In the right subtree, we will not be visiting this node first, because as you can see, in order traversal is left node then right. At each node we will apply this rule. So instead of visiting 5, we go to its left, we visit 7, then we visit 5, then we visit 8. Then since we have visited all the left subtree of 1, we can go ahead and visit 1. So you can see the figure wins in order traversal would be 4, 2, 7, then 5, 8, 1, and so on. Excuse me. Now what we can do is we will keep going to the left of this node, while current node we will go, and we'll keep those nodes in the stack like this, so that we can revert back to those nodes and process that stack nodes, right nodes as well, because we have to traverse the right subtree also after traversing the left subtree. So we will append the current node to the stack. Now you would be thinking, if I write while stack just here, stack is initialized empty, it will not run, right? For that we will be putting another condition here. Just let's first write some code here, and then I'll tell you why I will be writing another condition there. Yeah, now we will change our current node to current node dot left. So like at the end of this loop, we will be at the leftmost node. Now we know that since we are at the leftmost node, our current leftmost nodes left null, because at the end of this we will be assigning current node equal to current node dot left, right? So we will be in we will have a none node, not a none, it's not a node, but it indicates it is left node of a leaf. That's why it will be null. So but we know that we appended that to the stack. So what we will do, we will take the current node as stack dot pop, and we know this is the leftmost node. So we will append that node's value to the response or the resulting array, like this node dot val. Now we have the current node as the uh, leftmost node, right? If we what if we just keep it current node as it is, you will see that it will go in here and append the same node again, right? Because if you just keep the same current node, it will just keep on appending the same thing and popping the same thing and appending the response dot append the current node's value. So what we will do, we will change the current node to current node's right node. Why we are doing this? So remember, in order traversal iteratively, we never keep the right node in the stack. Why? Because if we go to any of these right nodes, suppose we go to from 2 we have traversed 4 and we go to 5. At 5 we don't keep track of 8 here directly. What we do, we keep going to the left subtree. If we add anything more than 7, we would have keep going to the left of the 7. Then later we would come back at 5, and now what we will do, we will just at the end of our inner loop, we will just pop this 5, then append this value to the resultant, and then we will set the current node to 8 so that we can go to current node this 8's left subtree as well, and so on. So we can do current node equal to current node dot right. But you would be thinking, if we did this, this will be become 8 will be working fine, but after that it will be assigned to null. Then what will happen then? For that, as I mentioned previously, we will put a different condition here, while current node. So if our current node is either of our current node or stack is not none, that is none of them are is empty or the none node, we will keep going on. So this will satisfy the need. That's why I was previously talking about there would be another condition put here, and we are almost done. So now we will return the response, and this is the solution for inorder tree traversal. 132 submit, and it is accepted. Thank you guys.